Hello dear students. On behalf of Department of Collegiate and Technical Education, I welcome you all for the LMS System of Education for the 5th semester Applications of Electronics Engineering. And in this subject, in this session, we are going to learn the last session of the audio system, the third chapter. So in the previous session, we studied about the microphones, the different types of headphones, and how it works, and the feature of headphones also we learned, and their advantages and disadvantages we learned it. So in this session, we will be learning about the special type of speaker called as loudspeaker. And the content of this session includes the loudspeaker introduction, the types of loudspeaker, the basic loudspeaker and the crystal loudspeaker and its features. And along with it, we will be learning a special type of loudspeaker called as woofers. So loudspeaker, we usually represent it with this type of diagram. This is the representation of the loudspeaker, which is just shown diagrammatically. And this is the loudspeaker in which the round like structure, what is visible over here, these are the two speakers, two loudspeakers that has been incorporated in this box. So what this loudspeaker is? The loudspeaker is an electroacoustic transducer. It's a device which converts an electrical audio signal into corresponding sound signal or into corresponding sound waves. The most widely used type of speaker is the dynamic speaker, and the sound source must be amplified or strengthened with an audio amplifier before the signal is sent to the speaker. So this is the explanation of the loudspeaker or the definition of loudspeaker. So the loudspeaker is an electroacoustic transducer which is converting any electrical audio signal into the corresponding sound waves. That can be called as a loudspeaker. What are the types of loudspeaker? These many are the types of loudspeakers. There are electrodynamic loudspeakers, crystal loudspeaker, electrostatic loudspeaker, horn loudspeaker, cone loudspeaker, and dome loudspeaker. So depending on how it is manufactured, how the structure is made inside, what are the materials that are used inside, depending on that, these loudspeakers has been classified. So to tell the features of an ideal loudspeaker is, ಒಂದು ಲೌಡ್ಸ್ಪೀಕರ್ ತುಂಬಾ ಉತ್ಕೃಷ್ಟ ಮಟ್ಟದಲ್ಲಿದೆ, ತುಂಬಾ ಗುಣಮಟ್ಟದಲ್ಲಿದೆ ಅಂತ ಹೇಳಬೇಕು ಅಂತಂದ್ರೆ ಅದರ ಗುಣಲಕ್ಷಣಗಳು ಹೇಗಿರಬೇಕು? So that tells you the feature of an ideal loudspeaker. So these are the 7 ideal feature that any loudspeaker must have if it is a good quality one. So the first and foremost is it should faithfully reproduce transients as well as steady input signals. So it must be faithfully reproduce the signal. Signal ಹೇಗಿರುತ್ತೋ ಅದನ್ನ faithful ಆಗಿ ಅದೇ ರೀತಿಯಲ್ಲಿ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡುವಂತ ಎಬಿಲಿಟಿ ಇರಬೇಕು. And secondly, the uniformity of the frequency response. Frequency response ಗೆ ಒಂದು uniformity ಇರಬೇಕು. So that is the second feature. And thirdly, the electroacoustic efficiency, which must be approaching to 100%. And the fourth feature is it should be capable of producing a non-directional radiation pattern. Because if it produces a directional one in only one direction, the sound may be listened. So if the sound has to be listened and it has to be spread out, then any loudspeaker must produce a non-directional one. So by this case, the loudspeaker can spread out the sound waves in all 360 degrees so that in an open area, it can be heard by all participants. So it must be capable of producing a non-directional radiation pattern. And in the fifth point is it should not introduce neither harmonic nor intermodulation distortion into its output. ಯಾವುದೇ ರೀತಿಯಾದಂತ distortion ಅನ್ನ produce ಮಾಡಬಾರದು, harmonic waves ಗಳು ಬರಬಾರದು, so that clarity will be missed. And next feature is it should have an acoustic output response that is independent of frequency over the entire audible range. So acoustic output response irbeku. And at last, it should be as small as size as is possible considering the required acoustic output. So loudspeaker and ಕೂಡಲೇ ಸೈಜ್ ತುಂಬಾ ದೊಡ್ಡದಾದಷ್ಟು ಕ್ಯಾರಿಯಿಂಗ್ capability ಕಡಿಮೆ ಆಗುತ್ತೆ and holding capability ಕಡಿಮೆ ಆಗುತ್ತೆ. So the size must be as small as possible, but the required acoustic output must be very fine tuned. So that is the feature of loudspeaker. And in the next slide, these are the features, okay? And in the next thing we will be learning about, in particular, the crystal loudspeaker. So in this session, according to the structure, we mainly deal with the two loudspeakers, that is crystal loudspeaker and woofers. These are the main two types of loudspeaker in which we learn it with a block diagram, okay? So to explain you the crystal loudspeaker, so crystal loudspeaker, it is a loudspeaker in which movement of the diaphragm are produced by a piezoelectric crystal unit that is twisted or bends under the influence of the applied audio frequency voltage. So the diaphragm, to produce any sound waves, the movement or the vibration of the diaphragm is must. So this movement of the diaphragm is happened by the crystal loudspeaker by the concept of piezoelectric crystal unit, by which a piezoelectric effect is made inside the crystal that makes the diaphragm to vibrate. So Rochley salt crystal is the one which we use it for the crystal loudspeaker, and Rochley salt crystals have the property of becoming physically distorted. Physically distorted means it changes its physical shape when a voltage is applied across two of their surfaces. So this property is the basis of the crystal type speaker driver. So we use it by this property of Rochley salt crystal, the crystal loudspeaker is used. So let us see the block diagram of it. So this is the block diagram of the crystal loudspeaker. See what are all the structures we have here. You can just see. This is the output transformer. This is the input section, primary section. This is the secondary one. From the primary unit, it is the supply of analog signal, analog electrical signal. At the output side, we get it with a low voltage, since it is a step down transformer that you can see by the number of turns. Primary turns are more and the secondary number of turns is lesser. So it is a step down transformer, since this is the primary and this is the secondary. And on the secondary points, we have two electrodes between which we have a crystal over here. So when an analog voltage is supplied to the electrode, the crystal will be deformated. Deformation means it is changing its shape according to the supply of current over here. So according to the change in electric voltage that is supplied by the analog voltage here, the electrode, the change in current in the electrode will deform the crystal. It bends back and forth, or it can twist to any of the angle. So the twisting of this crystal or bending of the signal or moving back and forth of this crystal will make the diaphragm to vibrate or move accordingly. So according to the movement of crystal, the diaphragm is moved or it is vibrated. So according to this vibration, the sound waves are created there. So these sound waves are change in diaphragm. The movement of the diaphragm is nothing but the air columns here are changed. According to the air columns, the sound output will be observed. So the crystal is clamped. The crystal is clamped between two electrodes across which the audio frequency output voltage is applied. And the crystal is also mechanically connected to a diaphragm. It is mechanically connected to a diaphragm. The crystal is connected mechanically to the diaphragm. So the deformation of the crystal caused by the audio frequency signal across the electrode causes the diaphragm to vibrate and thus produce the sound output. So the input impedance is almost completely capacitive one. So it's impractical to reproduce full audio frequency range. So thus power coupling is difficult. So speakers are normally housed in a separate enclosure or cabinet, which may be rectangular or square box made up of wood or plastic. So when high fidelity reproduction of sound is required, multiple speakers are mounted in the same cabinet. So as we have seen in the previous section of the cabin, in that cabin, in a one single cabin, we can find 2 to 3 or many number of speakers, multiple speakers are provided. So when the reproduction is needed more, inside one cabin, we can place more number of speakers in it. So each will produce a part of the audible frequency range. So in this case, the individual speakers are called drivers and the entire unit is called as loudspeaker. So anta case nalli individual unit na ನಾವು drivers ಅಂತ ಹೇಳಿ ಕರಿತೀವಿ, entire cabin ಅನ್ನ ನಾವು loudspeaker ಅಂತ ಹೇಳಿ ಕರಿತೀವಿ. So inside a large loudspeaker, it can contain many drivers. Okay. So this is about the crystal loudspeaker where the piezoelectric effect is the principle of operation used behind. So next we shall see woofers. So these woofers are low frequency speakers. It is a specially designed loudspeaker where it responses for the low frequency signals. So a standard woofer produces a frequency from 20 Hertz to 2000 Hertz. A standard woofer antandre. So there are two types of low frequency speaker and the commonly known as woofers and subwoofers. ಎರಡು low frequency speakerಗಳು ಬರುತ್ತೆ, ಒಂದು woofer and ಇನ್ನೊಂದು subwoofer. And the latter is used for the reproduction of frequencies below those produced by the woofer. And it's generally purchased as an add-on to the existing system. ಅಂದ್ರೆ woofers 20 Hertz ಇಂದ 2000 Hertz ವರೆಗೂ ಇರುವಂಥ ಫ್ರೀಕ್ವೆನ್ಸಿಯನ್ನ ಅದು ಅದರಲ್ಲಿ ಅದು ವರ್ಕ್ ಮಾಡುತ್ತೆ ಅನ್ನೋದಾದ್ರೆ, ಇಟ್ ವರ್ಕ್ಸ್ ಆನ್ 20 Hertz to 22 kilohertz woofers ಕೆಲಸ ಮಾಡಿದ್ರೆ, subwoofers are the one which is the very low frequency speakers. It can respond to the very low frequency also. So subwoofers drivers made for reproducing very low audio frequency, and a standard subwoofers will produce frequency less than 200 Hertz. 200 Hertz ಗಿಂತ ಕಡಿಮೆ ಇರುವಂತದಕ್ಕೆ ಅದು ಆಪರೇಟ್ ಮಾಡುತ್ತೆ. And the prime requisite for a woofer is the large diaphragm. ಅದರ primary requisite ಏನು, ಅದಕ್ಕೆ ಬೇಕಾಗಿರೋದೇನು wooferಗೆ ಅಂತಂದ್ರೆ ಒಂದು ದೊಡ್ಡ diaphragm, large diaphragm is needed, and how much it is larger, the better woofer it will be having. So the smallest diaphragm for any halfway decent woofer will be 8 inches. Smallest diaphragm use ಮಾಡುವಂಥದ್ದು wooferಗೆ 8 inches. ಆದರೆ ಸಬ್ವೂಫರ್ಗೆ ಅದಕ್ಕಿಂತ ದೊಡ್ಡದಿರಬೇಕು ಡಯಾಫ್ರಾಮ್, ಇಟ್ ವಿಲ್ ಬಿ ಅಬೌಟ್ 12 inches. ಸೊ ಇನ್ ಅಡಿಷನ್ ಟು ದ ಲಾರ್ಜ್ ಸೈಜ್, ದ ಡಯಾಫ್ರಾಮ್ ಮಸ್ಟ್ ಬಿ ಆಫ್ ಫೇರ್ಲಿ ಹೆವಿ ಕನ್ಸ್ಟ್ರಕ್ಷನ್. ಲೈಟ್ ಡಯಾಫ್ರಾಮ್ ಜಸ್ಟ್ can't hold up under the vibrations encountered under the low audio ranges. So a woofer must also have a large voice coil to handle considerable heat. So the larger the voice coil, the more the current produced by the amplifier output circuit, and therefore the more the power the woofer can handle. So finally, a strong magnet can be of great help to move the heavy voice coil and cone assembly to well. So the better the woofer, the heavier the magnet assembly will be. So this is about woofer, and it can be divided into mid-range and extended range speakers. The whole speakers or loudspeakers can be classified according to its operating frequency level. So woofers are designed for the low frequency applications, that is from 40 Hertz to 500 Hertz. And subwoofers are designed for very low frequency applications, that is less than 40 Hertz. Subwoofers are designed for the very low frequency applications for less than 40 Hertz. And tweeters are designed for high frequency applications, that is 2 kilo to 20 kilohertz. And the speakers which will be designed for mid frequency and extended high frequency applications. And subwoofers. See, a one cabin can contain the tweeter, mid-range and woofers. See, this is one cabinet. Inside one cabinet, it may contain 3 or more speakers. So it is containing the tweeter as one speaker, mid-range as the another speaker, and woofers in the another speaker. So the diaphragm ranging in 8 inches. So subwoofers drivers made for reproducing very low audio frequency. So a standard subwoofer produces frequency less than 200 hertz. So it produces a frequency of less than 200 hertz. So that's about a simple explanation about the subwoofers. So now let us see how the construction of woofer is made. This is the working principle of woofer, how the woofers are designed, how it is constructed, and how it is worked. So to see the design, here we have two magnets by which in between we have a voice coil. So the light shaded part, it is a cabin, it's a supporting structure, and black part one is a magnet. In between we have a voice coil, and in between we have a spider, that's a connection, a physical connection from the frame to the voice coil, just a connection, and upon which we have a diaphragm here, which is diagonally placed at the two cases, diaphragm, these are the two diaphragm, and in between we have a dust cap, so that to avoid any dust particles entering inside the magnet and voice coil. Voice coil will be very lower in section, I mean the size is very lesser. To this voice coil, the analog signals will be supplied, and frame is the supporting structure. Okay, let us see how it works. A woofer is a technical term for the loudspeaker driver. Loudspeaker driver use ಮಾಡುವಂತ ಒಂದು technical term, it is woofer, and it is designed to produce low frequency sounds, typically from 40 hertz to 500 hertz. So the most common design for a woofer is the electrodynamic driver, which typically uses a stiff paper cone. This is a stiff paper cone used for the diaphragm, and it is driven by a voice coil surrounded by a magnetic field. And the voice coil, which is attached by the adhesive to the back of the speaker cone. The voice coil is attached by the adhesive, by the gum, to the back of the speaker cone. Speaker cone ಗೆ ಒಂದು ಗಮ್ ಇಂದ adhesive ಇಂದ ಅದನ್ನ place ಮಾಡಿರ್ತಾರೆ. When current flows through the voice coil, see, I told the current is supplied to the voice coil. When the current flows through the voice coil, the coil moves in and out like a piston. So ಯಾವಾಗ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಥವಾ ಅನಲಾಗ್ ಸಿಗ್ನಲ್ ವಾಯ್ಸ್ ಕಾಯಿಲ್ಗೆ ಸಪ್ಲೈ ಆಗುತ್ತೋ, ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ಇಂಟೆನ್ಸಿಟಿ ಆಫ್ ದಿ ಕರೆಂಟ್, ದ ವಾಯ್ಸ್ ಕಾಯಿಲ್ ವಿಲ್ ಮೂವ್ ಇನ್ ಅಂಡ್ ಔಟ್ ಲೈಕ್ ಎ ಪಿಸ್ಟನ್. ಪಿಸ್ಟನ್ ತರ ಮುಂದೆ ಹಿಂದೆ, ಇನ್ ಅಂಡ್ ಔಟ್, ಒಳಗೆ ಹೊರಗೆ ಮೂವ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, ಲೈಕ್ ಎ ಪಿಸ್ಟನ್ ಮೂವ್ ಆದಂಗೆ ಇಂಜಿನ್ ಅಲ್ಲಿ. ಸೊ ದ ರಿಸಲ್ಟಿಂಗ್ ಮೋಷನ್ ಆಫ್ ದ ಕೋನ್ ಕ್ರಿಯೇಟ್ ಸೌಂಡ್ ವೇವ್ಸ್. ಯಾವಾಗ ಇಲ್ಲಿ ವಾಯ್ಸ್ ಕಾಯಿಲ್ ಇನ್ ಅಂಡ್ ಔಟ್ ಮೂವ್ ಆಗುತ್ತೋ, in and out movement of the voice coil will make the diaphragm to move or to vibrate. ಇದು ವೈಬ್ರೇಟ್ ಆಗಕ್ಕೆ ಶುರುವಾಗುತ್ತೆ. ಯಾವಾಗ ವಾಯ್ಸ್ ಕಾಯಿಲ್ ಹಿಂದೆ ಮುಂದೆ ಆಗುತ್ತೋ ಡಯಾಫ್ರಾಮ್ ಮೂವ್ ಆಗುತ್ತೆ. ಯಾವಾಗ ಡಯಾಫ್ರಾಮ್ will start to move, it will produce the sound waves. So the sound waves are produced. So woofers are designed to produce the bass or low frequency portion of the audio frequency spectrum, and for woofers, designer does not choose the strongest magnet, as adding more magnetic flux and it will reduce the bass performance of a woofer because of the moving system becomes overdamp agirodrinda it will reduce the bass performance. So the designer will therefore chooses the magnetic flux level that provides the best compromise between the efficiency and bass response. So to sum up in a whole, a good woofer must have a large and heavy diaphragm. It must have a large and heavy diaphragm and a strong magnet and a high compliance and a large voice coil. The diaphragm must also be bigger in size, and it must have a strong magnet, and voice coil also must be the larger one. So if that is the one, the woofer will be a good woofer or the ideal one. So this is the explanation about the woofer. So in this session, we learnt about the loudspeaker, its introduction, its type, and the feature of an ideal loudspeaker, and how a crystal loudspeaker works, the principle of operation, and we studied about the woofers, subwoofers, and its low frequency applications. And also we studied about the internal structure of the woofer, construction of it, and how it works. So this is about the woofer explanation and the crystal loudspeaker explanation. So this is the last session of this third chapter, audio system. So by this session, we are ended with the chapter 3, audio system. Thank you. Thank you one and all for listening and going through all the 6 session of the third chapter. Thank you one and all.